record on this. It's whiteboard. I hope now you can see my whiteboard. So first thing, hypothesis. What is hypothesis? Hypothesis is nothing but assumption or any statement that we make or we take, and we would like to prove this assumption or a statement about anything, about some population, and we would like to test this assumption based on the sample. So very simple assumption I would like to make, and there are, let's say, there are 150 students in BADM 503, and I will not get the real age of everyone. Let's say I can make 2-3 assumptions. Number one, the average age of my BADM class students is, I would say, like 30 years. So this is assumption I made it. The average age of this class is 30 years. So basically this is based on mean, or you can say average. I want to check it. So all 150 students are not available. I can get a sample of, let's say, 25-30 students, and then I can, based on that, I can do that. So this is just a simple example of 150 students. Think about some population where 100,000 people are there, at least not 100,000, any sample, any population has, let's say, 5,000, 10,000. You can't get all this data. Therefore, this is, similarly, it is also based on proportion. And it is also based on variance or standard deviation. Like, in last, so what would be the proportion? This is the, let's say, Eastern Washington students, male or female ratio. So I can assume that, proportion of EWU female versus male students ratio is, or proportion is, I can say 40% female, or I can say 40% females are there in Eastern Washington University. So that could be a proportion. Variance, I can say similarly, the variance of Eastern EWU students age is, let's say, 7 years, or in simple way, I can say 9 years, because variance is 9 years, or I can say in similar way, the standard deviation of EW students age is 3 years, because 9 and the square root of variance is standard deviation. So basically, hypothesis testing, we are going to learn on mean, based on proportion, and based on variance. So these are the 3 concepts we have to keep in mind, and it is exactly the previous chapter, based on previous chapter. Only one extra thing we are going to do here, which we are going to check the hypothesis option, and we are going to compare with benchmark. So what is this is a benchmark. Let me take one thing. So let me take this hypothesis, and let me do the statistics. So I'm just going to show you Minitab. I think you can see this Minitab, and let me start this. So my hypothesis, you see that hypothesis is that average age of my BADM student is 30 years. Okay. I would like to check this hypothesis. So what I'm going to do here, I'm going to create hypothetical, or
You can't currently see your screen.
oh, just thank you. Just a minute. So new screen, just a mini tab. Where is? Can you see mini tab?
Yes, I can see it now. Thank you.
Okay. Thank you. Remind me, because I'm just, so this is, I'm just going to almost 25 students getting their age. So basically I'm just creating a random numbers here, integers. So I go under, here we have integer. So no, minimum value, I'm just going to do, let's say somebody 22, maximum value is 40. And input column, no, I'm just integer. So data, and just okay, random data, here's integer. So number of rows too, so I'm just going to generate 25 store in age. Minimum value, so I'm just deciding a age of, in my class is minimum 22, maximum 40, and I'm going to, so this is the 25 students. Now I would like to go under statistics, basic statistics. I don't have the entire 350 or 150 students standard deviation of their age. So I'm just going to use one sample t-test. Now one sample t-test, here I have the data right here in this. Now hypothesized mean that I decided hypothesized mean is 30, isn't it? Now this is the, let's say, by default, I'm just taking 95, and I'm just taking equal, not equal sign, because I have decided 30 years. I'm not making more than 30 or less than 30. So let's just very simple. And now here we got the t value, we got the p value, and we got the null hypothesis mu equal to, so let me make it bigger. So this is t value and this is a p value. Now t value is 1.22, p value is 23%. What is your conclusion? Anybody can tell? I'm going to explain. Certainly that is. So p value is 23%, means probability is 23%, 23.4 precisely t value. What we can say? My assumption is correct or my assumption is wrong based on these 25, based on 25 students sample. Any guess? Yes, I'm correct. Why? Because you can see, so I took 95% confidence interval. So 95% confidence interval, let me see what is the value, critical value for 95%. So I just go here and I can go under T. Where's the T? T right here. Degree of freedom. So I have 25 students. Now degree of freedom 25 minus 1, which is 24. Now I would like to go 5%, and I would like to go, half and half here. So basically, so you can see this is my plot. Anything between minus 2.06 to between, this value, my null hypothesis gets accepted. what? My null hypothesis is accepted. So my, t value is coming almost one. My t value is coming almost here 1 point. I forgot. So my t value is coming here 1.22. So 1.22 would be certainly right here, somewhere. So this is means this is acceptance region. Acceptance of what? Null hypothesis acceptance. Null hypothesis is H0. This is the way. So this is acceptance and this is rejection. So if suppose t value would be more than 2.06, then our null hypothesis will reject. Null hypothesis will reject and alternative will be considered. So any value after this or any value below this is in, so red is rejection region. This is rejection region of null hypothesis. And therefore my null hypothesis is accepted. Yes, 30 years is the average age of my BADM course students if I take all with 95% confidence. Again, so this is hypothesis testing. I made some assumption or like, we are sitting right here and me and, Dennis has a, we are talking, I said, average house price in Ellensburg is this much, or average house price in Spokane is this much in South Hill area. So we decided, okay, 400,000 is average age. He said, no, I think it's less than 400,000. Then, okay, he is not, agreeing with me. I'm not agreeing with him. How we can see who is correct? Then, we decided, okay, this is going to be our benchmark value for, we are going to test again 400K. Let's collect the data, collect of, 40 or 50 houses, run this based on that, 90%, 95%, and we can check and we can decide, okay, what is correct? It is 400K, it is less than 400K, or it is more than 400K. So this is the purpose of hypothesis testing. Similarly, you can say about a salary, in particular profession, you can say the salaries should be about this. Now you want to test your hypothesis, check the, collect the salary of like 25, 30 or 40 people, check it and know it. So this is the meaning of hypothesis testing. Now, is it making sense? If this is making sense, I would like to explain based on slides and based on. So if application is clear, let me make one more, thing here, one more important thing. What is the meaning of this p-value? So based on t-value, you can decide your hypothesis, null hypothesis as accepted or rejected. This is another way to do this based on p-value. Why? So because of probability, certainly this is a probability. You are testing at 5%, means you are testing the null hypothesis at 5%, or your but your value is 23.4%, means you need more, less confidence interval in order to do that. Let's see what is the value for this. Oh, so 0.234, what is the t value? So basically, let me explain this part and then. So, this is, you are trying to, you have this much margin, you want to try and test your hypothesis in this bigger space, but actually you are getting your hypothesis approved within this, this range. How? Let's see. So another option to do using p-test. So 0.234. So let me go with graph probability distribution. and I go here and T again. So basically I'm just going to do here. Now I would like to put probability value 23.4234. So you wanted to test your hypothesis in this much range, which is, minus this much range, you can say, but it is getting accepted in a smaller range because it is, you want how much? 23.4. So half is here, half is here. That means within less, therefore your probability is more of acceptance. So always, how do we decide? If p-value, this is a thumb rule, always remember p-value is greater than alpha, where alpha means significance level. Then you accept null hypothesis. So these are the two ways to accept. One is based on critical value, one is based on p-value. Now, if this is clear, now I'm going to explain the basic concept, what is the null hypothesis and how it is used. So again, I am going to go on whiteboard. So null hypothesis is always written like this. And it is colon mu equal to, like I said, mu equal to 30. Alternative is written like HA or H1. Both symbols are used alternate, different. So HA, let's say mu is not equal to 30. Please, bear with my writing because I'm using mouse. So this is null hypothesis. Now, yeah, there are steps to do null hypothesis. So I will explain that also. What is the meaning of this? Why we call it null hypothesis? That is another question. Why we call it null hypothesis? So there is a concept. Null means no. No or zero. That means whatever you are hypothesizing, there's no difference between hypothetical value that you are and the actual based on the sample. There's no difference, zero difference. Therefore, it is called null. Alternative is there's a difference between your assumption or your statement and actually based on sample. Therefore, null means no difference. Alternative means difference. Is it clear why we call it? Now there's a process of testing hypothesis. There are 4 or 5 steps. Number 1 is, write null and alternative. Second, decide at what level. So basically alpha. 5%, if there is no alpha given, automatically you select 5% or 95% confidence interval. So alpha or decision rule. Sorry. So alpha or decision rule. What is alpha? So alpha is also known as significance level. That significance, if confidence in, so let's say if I say 95% confidence, means 5% significant, 5% significance. Or if I say 5% significance, automatically you can say 90% confidence. So this is, you know very well. The third is collect data. Collect data, or if you have summary, summarized data. Then fourth is test statistics. That means calculate t-value and p-value. Means T, Z, or P, calculate statistics. Number 5 is make your, accept or reject. We fail to reject, basically, accept or reject null hypothesis. And make your, sixth step is make your decision, So these are the 6 steps normally in any hypothesis testing we are going to do. But since Minitab is there, it automatically does all these things for us. So basically, this is a traditional way to do this. Now, so this is exactly based on proportion. This is exactly based on what you call variance and standard deviation. We go and we do like, so basically, how do we write in case of proportion? So writing is like, so here, okay, so H0 here, pi equal to whatever, or pi not equal to, so this is alternative. In case of H0, so here this is for variance, sigma upon, this is for, I'll show on slides. So let me go one by one. Now I'm going on slide part. So I hope you can see my, so hope you can see my slides. If yes, get an idea, formulate hypothesis, gather data, find test statistics, make decision, revise. So basically, different authors have different steps, but this is typical hypothesis testing. So exactly, I already explained null hypothesis, alternative hypothesis, some author also. So can hypothesis be proved? We cannot. So basically, technical wording is about hypothesis is we cannot accept a null hypothesis. We can only fail to reject it. So we don't accept null, we fail to reject the null hypothesis. So this is, technical. If you are going to accept, we write fail to reject it. But, in simple wording, we accept null hypothesis or reject. So this is the technical way. Now there is another way. I mean, 2 important problems that in terms of error of null of, hypothesis acceptance and rejection. Here, very important thing. H0 is true, H0 is false, reject, fail to reject. If H0 is true, reject null hypothesis. That is type 1 error. H0 is false and reject null hypothesis, that is correct decision, which is, it is, false and you are rejecting, that is 100% correct. But H0 is true, you are failed to reject, which is, correct decision. Again, if null hypothesis is true and you fail to reject, which is correct. But H0 is false and you are failed to reject null hypothesis. This is another. So this can be possible in hypothesis testing. Let's say, you can take an example. You have COVID, but COVID is, so basically you have, let's say, somebody has a COVID and COVID is not tested positive. Patient is not tested positive, so test is not showing the positive, but actually, on the other side, person is not positive and it is showing positive. So similarly, here, this situation can also be possible. Hypothesis is true, but it is, you reject it. So it is also called type 1 or type 2 error. It is also called alpha error or beta error. And I will explain about this, how to deal with this. So I'm not going into this type 1 and type 2 error because this will become more complex once you understand this. And we don't have a question related to this in our this. Otherwise, we have to go into power calculation and other calculation that is more complex. So, but simply understand true, but even you are rejecting, that is type 1 and type 2. And I can, demonstrate few examples. So decision rules and critical values, left tail, two tail, right tail test. So this is, equal or not equal. So these are three ways you can frame the hypothesis. One is, you will see the homework part and in fill in the blanks, you have seen that it is more than or less than, the mean value is exceeding or mean value is lower. So basically left tail test, on the left side of the curve, right tail test on the right side of the curve, and two tail is 50-50 means both side. We already learned this in our previous normal distribution and this. So these are the three hypotheses we can frame based on mean. Mu is a mean. Like I just gave the example of left tail reject H0 of test statistics is, less than critical value. What is the critical value, which is the ideal value, or you can on 5% test significance level, what are the T values? Two tail test, half here and half there, right tail test, on other side. So I'm just taking the same example that we used. So since we already tested this, that our mean age of the student is 30 years. Now I'm going to create one more thing and let me see, or I can frame this. My hypothesis is now, null hypothesis is H0 is less than equal to 30. Alternative is H0, or, since this is proven, I just take, 25. Null hypothesis, I say, the average is, the age of the all student is less than or equal to 0. Less than or equal to 25, sorry. H0 is, alternative is automatically is more than 25. So let's take the same data and let's play with. So I go here, statistics, basic statistics, one sample T. And now I'm going to change only one thing, which is I'm going to make it 25. And here under options, we have three options, and make sure these are alternative. It is not null hypothesis. These are, so what is our alternative? H is greater than, so mean is greater than hypothesized mean. Okay. And now I'm going to do it. Now, what do you see? This is T value is 5.25. p-value is 0. That means what we can say? So very simple, null hypothesis, when we can accept null hypothesis. So this is null hypothesis. If p-value is greater than p-value for null hypothesis, p-value should be greater than alpha value. Alpha is 9. So our p-value is, but this is, so null hypothesis is rejected. And automatically once it is rejected, this is accepted. That means average age is more than 25. So alternative is, or H1. Therefore, we can simply say, so this is rejected, which says equal or less than 25. No, this is not true. This is true because p-value is 0. So p-value is less than alpha. We reject null hypothesis and we conclude that average age of the students more than 25 years, which is, so this is p-value is a decision point. So this is, similarly, you can, do opposite case, which is you can say, so this is, related to mean. So decision rule, p-value, you can see this is rejection region. This is rejection region in two-tail. Left, this is rejection region. Rest is, acceptance region. So basically acceptance is for, null hypothesis. Don't reject right tail, this area is for don't reject, this solid area is for rejection. And critical value is this. Beyond that value, you can reject. And how do you get the critical value? Simply going on Minitab and getting the critical value, like we did in this case. So in this case, I think this is the one. So in this case, we got critical value 2.064, and so these are the two critical values we can directly plot from, and we can get these numbers if you don't want to see, or for 95 or 90% or 99% confidence, there are critical values given, and everyone can remember easily since you have already done last chapter. So this is critical. Type 1 error. Now what can be the possible thing here? Let's say we did, this hypothesis, this 30 years of age. Let's say if the decision is very close, like say if I'm assuming mu is 30 and our hypothesis is rejected with, very small value. Let's say due to, if I assume 30.5 or 30.2, hypothesis is rejected or accepted, then that is one issue. Other thing, confidence. If you increase the confidence interval, your hypothesis is accepted. So basically, how do we see this problem? I have to go. Let's say, this is your acceptance region and your t value is calculated value is coming 2.1, I would say, which is very close to here, which is very, very close to here, or 2 point, or you can say very close to here. It could be an error that due to, so if you increase little bit confidence interval, little bit, like this is 95%. If you increase the confidence interval, let's say 95.5 or 96, then, basically your hypothesis will be within range. So this could be other thing, changing the mean value. So for example, so this could be possible with, increasing the confidence interval due to you have selected wrong, little bit different confidence, your hypothesis can accept and can reject. Similarly, the mean value which you are selecting 30 or 31, if the average is very, so let's say this mean is coming 31.5. So let me do this same statistics with 32 or 31 point something. So let's say I'm just going to put here 31.5. Okay. And rest, this is, so 31 point, t value is 0.0 and p value is, so even again this is getting accepted because, but if I do little bit more, t, what is, if I 0.7, let's say I am saying the average age of all the student. So even, in this case, it is getting accepted. So any value which is very, close to this, and there, with changing little bit value, it can accept or reject. There, that is also a reason for another error, that selecting this value, which is, benchmark value, which is like 31.7 or 30, and our hypothesis can be accepted, can be rejected with decimal difference. That could be another error in order to make the decision of correct value. So here, these two errors are possible. We are not going into deep into this part. Now, same, if you have population standard deviation, you can do that G test. So this is testing mean known population variance. Known population variance means known standard deviation. So here H0 is less than equal to 216. I think you have the example. So exactly the same process we have to follow in order to reject or accept the null or alternative hypothesis. So take action, basically, these are all p-value is another. I already explained about p-value. If p-value is less than alpha, that means we reject null hypothesis. When do we accept null hypothesis? If p-value greater than alpha. So I already explained this part, in simple way. Two-tail, I think I already explained all these concepts. Since everything is calculated based on, so for two-tail, you just consider the p-value half here, half here. So if sigma is unknown, means population standard deviation is unknown, then we go for t calculation or t statistics. So it is very clear in this, we already practiced in the last module. When do we use z-test? When we know the population standard deviation. In fill in the blank, there is one or two question that gives you the population standard deviation, that does not give sample standard. So you have to do this. And if sample statistics or sample information is given, this is the case. If proportion, this is the case. For variance, this is the case. One or two is about variance. one or two about this, mostly question about T statistics, one or two questions about Z out of 20. So major questions are based on T. So, exactly the same thing we are going to use in all. Confidence interval, how do we choose? How do we decide? Since you have already done, I'm not going to explain here. So this is about chapter number. So here pi equal to pi 0, pi not equal to pi 0. Proportion hypothesis can be written in this way. Similarly, variance. So variance is, the sigma square equal to sigma 0 square. That means whatever both variance are equal, one is equal, one is bigger. So basically this is explained in this manner. So variance are equal, population variance is smaller than sample variance. Population variance, so you can do all three different ways of variance, and it is used based on chi-square statistics. So this is three way of doing hypothesis based on proportion, based on mean, based on standard deviation or variance. Now you have question, please tell me. If you have any question, please tell me. I will try to answer. If you want to see any test, or just tell me so I can, explain here more. Because this is exactly, one thing which I would like to, again explain here is based on proportion. So here, if you see statistics, basic statistics, one proportion. Let's say number of events 25, hypothesized proportion is this. Now remember, you have n pi and n1 minus pi. When do we use this exact value? When do we use normal approximation? Always keep this principle n pi greater than equal to 10 n 1 minus pi. So check this thing, and you can select which option. If this condition fulfill, then you go for normal approximation in proportion. This is always there. Otherwise you can use. So let's see in this. I think this is number of events are 16. You are doing 25 tries. Hypothesized proportion is 50%. So, number of tries is event 16. So 25 into 5, more than 10, 1 minus, which is also more than 10. Therefore, we are going to do normal approximation. And what is the hypothesis? I don't remember. You can do this 99%, 95%, or whatever. So let's say I'm just going to do, and you can get, if you do normal approximation, you get Z value. If you don't use normal, you can only get the P value. So here you can see the Z value, P value, and let me do this same equation, same calculation, but I don't choose this option. I choose exact. You won't get you only get the P value. Okay. So this is another important concept that you keep in mind before doing this. Any question, please let me know.
Hey, Professor,
Yes.
can you hear me?
Yeah.
I have a question, not related to this, well, actually it's kind of related. In the video that you have for the module, you have a data set on Indian students accepted to US universities. Do you mind sharing that, or have you shared that with us?
So, in this module, basically you can see all the questions right here. And that is, I think, in the next course, I can share the data, to do your statistics and all, no problem.
Yeah, because I like to follow along in Minitab as you're working the problem.
Yeah, so yeah, I can, share that data. I can post right over there in announcement section, because that is, I collected, and so yeah, I will share, no problem.
Oh, cool. Thank you. Appreciate it.
Yeah, but the homework is not based on that. You can practice for yourself.
Okay. Thanks.
Okay, you will see an announcement part just after 5-10 minutes after the class. Any other question? This is very easy chapter. The most difficult chapter was, and I think and another important announcement I'm going to make right here. Our final exam will be based on 1 to 5 module. We will not consider 6th module in the final exam, because we will not have. So 6th module is not in the final exam. Final will be based on 1 to 5, means up to hypothesis testing. Okay, if you don't have any question, I would like to say good night. Have a wonderful night and a wonderful week ahead to all of you. And we'll see each other next class.
Thank you.
You're welcome.
Thanks very much.
Yeah, most welcome.
Thank you.
Most welcome.
Would you mind sticking around after this session and see if we can answer the question 6 that I've been going back and forth with you?
Question 6.
Yeah, on the fill in the blank. I sent you another email.
Oh, I did not. I mean, if you sent recently, I did not check, but otherwise, what is the question? Can you tell me?
Yes, hang on.